Hey guys, let's have a look at assessment 9, which covers composite shapes, converting units of area, probability, and simplifying ratios. If this is your first time through this assessment, or it's been a while and you're using this for practice, make sure you hit pause and try these questions for yourself first before we go over the answers at the end. Right, let's get started. This first question is about a composite shape and finding its perimeter and area. This next one is converting the units of area. Next, we've got a probability question, another different type of probability question, and then a different type of probability question because of what we know about probabilities, the properties of probabilities, and how we can use probability to form expectations about outcomes, simplifying ratios, and again, writing a worded problem as a simplified ratio. I hope you've had a chance to go through those. If you struggled with any of it, have a look at the links down below before we go on to the answers. Maybe you need to go through some of our lessons first. Let's go through these answers now. First, this composite shape. We can work out the perimeter of a composite shape so long as we know the lengths of all of the outer sides. Now, some of these sides here are not labeled, but look at the markings on the shape. These double markings that I have here mean that these two side lengths are the same length. So if this is 12 centimeters, so is this length. These single side lengths here tell me that they are the same length, but I don't know what either of them are. So first I'm going to need to work out what they are. I can compare the horizontal length, so this is 17 centimeters, with the horizontal length on the other side, this is not sure what, plus 12 centimeters. Those two lengths should add up to 17. So if I do 17 minus the 12 that I've already got, I'll be left with another 5 centimeters here. So I've got 5 centimeters up the side and I've got 5 centimeters across the top. Notice that this 5 plus this 12 makes this 17, and this 5 plus this 12 makes this total of 17. So it all works out nicely. Now let's work out our perimeter by adding up all the sides. It's generally best to choose to start from one side and work your way clockwise around the shape so you don't miss anything out. So my perimeter is 5 plus 5 plus 12 plus 12 plus 17 plus 17. I've got them all, and that adds up to 68 centimeters. So our perimeter is 68 centimeters. The area is a little bit trickier to find. We don't have a formula for the area of a shape like this. However, we can split the shape down into parts, and to find the total area, we'll find the area of one part and add it to the area of the other part. Now I'm splitting this shape down into two rectangles because I clearly know the formula for the area of a rectangle. Area A has got length 5 and width 17, and area B has length 12 and width 12. So to work out their areas, length times width, I'm going to do area A is 5 times 17, and area B is 12 times 12. That gives us 85 plus 144, which is a total of 229 centimeters squared for the full shape. Notice my measurements were all in centimeters, so my area is going to be in centimeters squared. Next, converting units of area. Now this time I've just given you the area of the rectangle, so there's no possibility for you to convert the length and the width to millimeters first and then work out the area. We need to convert the area directly from centimeters squared to millimeters squared. Now I know a lot of you will be making mistakes on this because you need to revise how to convert units of area. If you don't practice it, you will definitely forget it, and I'm counting on you to remind those who do forget it. Okay, so remembering that to go from centimeters to millimeters, we multiply by 10. Most people can remember that. However, what they don't remember is that to convert centimeters squared to millimeters squared, we have to multiply by 10 squared. That's multiplying by 10 and multiplying by 10 again, which is not multiplying by 20, that's multiplying by 100. 10 times 10 is 100. So to convert 180 centimeters squared to millimeters squared, I need to multiply by 10 squared. That's multiplying by 100. That's adding on 2 extra zeros, so shifting all the place values up 2 spaces. That's 18,000 millimeters squared. Now to convert this from centimeters squared to meters squared, start out with what anybody could tell you, I hope. From centimeters to meters, we divide by 100. But from centimeters squared to meters squared, we divide by 100 squared. That's dividing by 100 and then dividing by 100 again. That is not 200. That is 100 times 100. That makes 10,000. So we need to divide by 10,000. An easy way to do that is to count the zeros in the number 1, 2, 3, 4. And I need to move all of these place values down 4 place values. So that means moving my decimal 1, 2, 3, and 4 places, leaving an imaginary 0 there. So I need to put 0.018 meters squared as my answer. If you're new to this, if you didn't know that conversion, check out the link below. Next, theoretical probability. This is theoretical because we have a certain number of kittens. Some of them are male and some of them are female. So the probability that the female kittens gets adopted first depends on all of the possible outcomes that we have here. The probability that any event A happens is the number of ways that A could happen divided by the total number of possible outcomes, or the total number of possible things that could happen. So if we have 3 females plus 7 males, there are 10 kittens in total. So the first kitten to get adopted could be any of these 10. The probability that that kitten is a female would be 3 out of the total number of possible outcomes. So 3/10, or as a decimal, we write that 0.3, 3/10. Right, this next question is about experimental probability, because one could say theoretically an egg might have 2 yolks or it might not, so there's only 2 possible outcomes, so there's a 1 out of 2 chance of having a double yolk, but we know that that's not true. So Tom, this chicken farmer, has decided to conduct an experiment. He's looked at 250 eggs and counted that 5 of them have a double yolk. That's not half of them. So he's using this experiment to decide what the probability is of having a double yolk egg. For experimental probability, we look at the number of times an event occurs out of the total number of attempts. So in this case, the probability of a double yolk we will assume is 5, because we saw 5 double yolks, out of 250, the total number of eggs we included in the experiment. That simplifies to 1/50, dividing both top and bottom by 5, or as a decimal, that would be 0.02. If you say this is the same as 2%, that's correct, but if you forget to put the percentage sign, it will be wrong. So our probability is 1/50 or 0.02. Next, we're looking at probability again, but we need to remember one of the properties of probability is that probability is always a value between 0 and 1, 0 being impossible and 1 being certain. And the probability that any of the possible outcomes happen should add up to a total of 1. So here when we're talking about the probability of having surfable waves and the probability of not having surfable waves, those are all of the possible outcomes. So if I add those two probabilities together, the probability that there are surfable waves plus the probability that there are no surfable waves, that should add up to a total of 1. Now I know what the probability is that there are surfable waves by looking at the wave forecast, and I'm told that that's 0.13. So 0.13 plus the probability that there are no surfable waves should add up to 1. To find the probability that there are no surfable waves, I'll get that on its own by moving the 0.13 to the other side. On the left-hand side, it's adding, so on the right-hand side, I do the opposite, I subtract. The probability that there are no surfable waves this weekend will be 0.87. Next, probability and expectation. Now, if I don't study for my test, and I know that the probability that I get any one question right is 1 out of 4, I would expect that I would get some fraction of the answers right still. Certainly not all of them, but not none of them. Some fraction of my answers will be right. And that's the definition of expectation. The expected number of successful outcomes will be some fraction of the number of tries. Remember that probability is a fraction that is very closely linked to the number of correct outcomes. So the expected number of successful outcomes is equal to the probability times the number of tries. Remember, that's a fraction of the number of tries. So in this exam that I'm taking, where there are 24 questions and the probability of guessing a question right is 1/4, I would expect to guess 1/4 of those questions right. That is, I expect to get 1/4 of those 24 questions right. And 1/4 of 24, or 24 divided by 4, is 6. I expect to get 6 questions right just by guessing. That doesn't mean I definitely get those 6 questions right, because it depends on luck. Maybe I get more, maybe I get less. But I would expect to get 1/4 of those questions right based on that probability. So the expected percentage that I get on this test, I could either say I would get 6 out of 24 and turn that into a percentage, or I could look at the fraction of the questions I expect to get right, which is 1/4, and I'll convert that fraction into a percentage. 1/4 is the same as 0.25, doing 1 divided by 4, and to turn that decimal into a percentage, we times by 100. So that's going to be 25%. Not great. Better get studying. Next question is simplifying ratios. So I'm given 3 different ratios here. And to simplify a ratio, much like how I simplify a fraction, I need to find a common factor. That is a number I can divide both sides of that ratio by. For question A, I can divide both 12 and 16 by the factor 4. That's my highest common factor for 12 and 16. 12 divided by 4 is 3, and 16 divided by 4 is 4. So my simplified ratio is 3 to 4. For question B, my highest common factor for 70 and 25 is 5, and 70 divided by 5 is 14, and 25 divided by 5 is 5. So my simplified ratio is 14 to 5. Lastly, 9 and 15 have a highest common factor of 3. I can divide 9 by 3 and that gives me 3, and 15 I divide by 3 to get 5. So my simplified ratio is 3 to 5. Now our last question is a simplified ratio question. It's a worded question, but hopefully it wasn't set out too confusing for you. There are 18 boys in a class and 15 girls. Write the simplified ratio of boys to girls. Remember, the order matters. And look, I was consistent with the order in the question. I started with the boys and I told you how many boys there were. Then I went to the girls and told you how many girls there were. And I want you to answer in the order boys to girls. Watch out for that, because on a really mean exam, they might switch the order on you. But generally, it's in the same order. So let's start our answer out showing the order of our values. So boys to girls. We're told the number of boys and the number of girls, so let's put that in the ratio under the appropriate side. 18 boys to 15 girls. And to simplify this ratio, again, we need to look for a common factor. The highest common factor of 18 and 15 is 3. So dividing both sides by 3, 18 divided by 3 is 6, and 15 divided by 3 is 5. So my simplified ratio of boys to girls is 6 to 5. For every 6 boys, there are 5 girls. Now I hope that you found this exercise helpful. And if you're still struggling with it, have a look at those links down below. The only way you get better is by practicing. So keep it up, and I'll see you with the next one.